something into the chat window? Yes, excellent. Thank you, Phil, for letting me know. Good. It's 4:01. We are ready to go. Thanks, everyone, for joining. Glad to have you here. As you probably know, you are all on mute. So if you need anything, please type into the chat window. I will look from time to time onto the chat window so that I can answer your questions there. And at the end, if it's a more complicated session, I can also open your microphone. Let's see if that is necessary at the very end. So again, thanks everyone for taking the time to join us here as COVID in the webinar. Glad to have you here. And today's session is about Kubernetes. So we are doing a deep dive and a small demo with Elastic Kubernetes service on AWS. So for those of you that have not been on those webinars, we have run them now for the 6th time actually already. So we have each month roughly a webinar and have looked at some great solutions from AWS. The agenda that we have prepared, it's roughly 45 minutes, the whole session. We really focus on Kubernetes as a service, and then we look at EKS as the Kubernetes service from AWS. And then we will go into the details, difference between EKS and EKS Fargate, a bit of networking, and then the individual solutions around the individual objects around Kubernetes with deployments and pods, and at the very end a demo that I show you live how EKS is built and what Kubernetes does for you as customers. So for those of you that have not been on any of those webinars, a very brief introduction. I have done that now several times, so I will not spend too much time on it. So COVID is a cloud native company. We are really born in the cloud, focus heavily on AWS, containers, Kubernetes, automation, and do cloud consulting. And we are fully Swiss-based, so we have 13 employees, Zurich and St. Gallen. So our clients are here in Switzerland. To myself, I have been roughly 25 years in IT, 15 years at Cisco, and I've been working quite a bit with AWS over the last 6-7 years. Got 8 AWS certifications, including DevOps and SA Pro. I also did Kubernetes admin, so hopefully I should know my way around over the next 45 minutes. And I do have hands-on with AWS, Google, and Azure Cloud, but clearly my preference is with AWS. I have most experience working with AWS. So for those of you that have been on the last month's webinar, there you have seen some of these slides already. Apologies for that, but we want to recap a bit what the container solutions are on AWS to have some stage setting, that you have some guidance when you should use what container solution on AWS. So primarily it's 2 big areas where AWS focuses on their solutions. That's the first thing is ECS, Elastic Container Service, and that is basically their own homegrown container orchestration solution that AWS brought out probably 8-9 years ago, so quite early in the container game, and they did that because Kubernetes was not around at that time. So when AWS started 2012, 2013 with ECS, Kubernetes was only available inside at Google, because as you probably know, Kubernetes came out of Google, so nobody else had access to that. So AWS brought out a solution that everyone could use, and that has been on the market for quite some time. And as mentioned before, the second solution is Kubernetes. Kubernetes is also available in 2 modes, so you can have it in EC2 mode, which we will focus on over the next half an hour or so, and also in the demo, but you can also have it in Fargate mode. And obviously, you can also have ECS in Fargate mode. In ECS, the Fargate mode is super convenient because you don't have to manage anything except the deployments and the pods, the containers themselves, and all the rest of the heavy lifting is offloaded to AWS, so not much to do. So for smaller clients or clients that don't want to have a lot of control, Fargate for both ECS and Kubernetes is really, really easy to use. But as said, you hand over a bit of control to AWS, because you don't see those nodes, you don't know exactly what is going on those nodes, and you have to trust that AWS is doing the right thing. And if you need control, for example, you need to install an agent, or you need to collect specific metrics or anything like that, then you can't use Fargate. Then you have to use the classic Kubernetes or ECS solutions. And of course, AWS also has the container registry. Container registry is to store images comparable to Docker Hub, but what you do with the Elastic Container Registry is you store your own private images on that one, and only you shall see. So now going into Kubernetes and what Kubernetes is. Kubernetes is an open source system for orchestration of containers. So basically, it helps in automating deployment, scaling, management of containerized applications. It came out of Google, so I mentioned that before. So Google has been running containers for a very long time. So they started to use containers probably 2005 or so, or even earlier, with the C groups on Linux. And when they started to go mainstream with containers, they needed a solution to orchestrate all these millions of containers that they run. And so Borg was born. Borg is their internal proprietary container solution, and Kubernetes was then open sourced in 2014 or so, I believe, when Kubernetes was donated to the Cloud Native Computing Foundation to help organizations orchestrate container solutions. And AWS has taken Kubernetes because many enterprises asked AWS to come out with a fully managed Kubernetes service as well, and that's when EKS was born. So I saw that during my time in Australia, I had quite a few customers running Kubernetes managed by themselves on AWS, and actually they wanted to have a fully managed Kubernetes solution. And at that time, AWS pushed quite heavily their own proprietary ECS solution. But with the push of the clients and the great customer focus of AWS, they brought out a fully managed Kubernetes solution. And basically, when you start Amazon EKS, you get a full Kubernetes cluster with all the bells and whistles of Kubernetes, and you don't have to worry anything about setting up nodes or setting up control planes or managing etcd or anything like that. You get a fully highly available Kubernetes distribution solution where AWS does all the heavy lifting for you. And then you have the normal Kubernetes APIs, so you can use kubectl or any other Kubernetes API compliant user interface, and go and manage EKS with the tools that you already know in the Kubernetes area. Why companies are using Kubernetes and not ECS is most of these enterprises, they want to be cloud agnostic. And with Kubernetes, you do have a service that runs on all the major cloud providers. So you have it at Google, you have it at Microsoft, you have it at AWS, even IBM and Oracle, and all these cloud providers, they do have Kubernetes services. So basically, when you build something on Kubernetes, you can run it anywhere you want. Every major cloud provider has a solution out there. Obviously, EKS is highly integrated into the AWS ecosystem. So it uses the ENIs, it uses Elastic Container Registries, it can use the secrets, it can do many of the cool things that AWS has. It can also use instant profiles and roles and all these value adds that AWS offers. You can also use them with Elastic Kubernetes Service. The architecture of EKS is twofold. So the first thing is AWS manages for you completely, regardless of the mode that you run, the control plane. So the control plane is handled and running inside of the EKS VPC. So you as an EKS customer don't see that. The AWS provisions that for you. Your master nodes, they are provisioned in there, and you don't have access to those resources. And then depending on the mode, you get access either via a private endpoint or a public endpoint to manage the API and the control plane access. And here you see also the logs and proxies and all those things that need to talk to the worker nodes. And the worker nodes, they are running inside your own account and inside of your own VPC. And they are fully exposed to the worker nodes via an EKS-owned ENI. That's an Elastic Network Interface that is pushed from AWS via their software-defined network into your VPC, and then all the communication is happening on the AWS backbone with the control plane. Meaning your worker nodes, they can be fully private, so you don't need to have them in public areas. So you can have them in private areas, so that all your workload is fully protected, and you can use all the goodies of the VPC as you prefer. So you can use flow logs, you can use sniffing, you can use redirection, you can use NACLs and subnet group, security groups. You can attach it to transit gateway, and all these cool features with VPN and so forth are all fully available because these are pushed in your customer VPC that you fully manage and fully own. So going a bit into the Kubernetes architecture, and these are complete new slides. You most likely have not seen them yet. The Kubernetes architecture is two areas where we will focus on. So the first one is the control plane. The control plane, which in the case of EKS is fully handled by AWS, is run on the master nodes. The master nodes, as mentioned before, are in a AWS managed environment, and there the API server, the controller manager, the scheduler, and etcd as the database are running on top of those nodes. And then you, as a developer or operator, or the AWS console, talks to the API and has controlling abilities of the Kubernetes environment. Then the difference is for running the applications, they are run on the Kubernetes nodes, or also called the worker nodes. The worker nodes, they are usually Linux VMs, or could also be Windows VMs, but usually they are Linux VMs, where actually the container images are run. So these are Docker images that you execute as pods and deployments and so forth, and you run them on these worker nodes. So here you see each individual pod, that's actually a container image that runs the workload that you have specified. And in these special processes that you see, for example, kubelet, that's the communication, and not the communication, that's actually the control process of Kubernetes that handles the worker nodes. the start and the stop and the integration into the CNI and CSI and all these things that Kubernetes requires is handled by the kubelet. And kubeproxy, that's a software component that handles networking inside of the worker nodes and also talks to the outside world so that the users actually can reach all these applications, these containerized applications. And on the bottom here, you see the network, that is based on CNI, Container Network Initiative interfaces. So basically, because we all have these different worker nodes, we need to cluster them together on the networking side, and that's actually what these plugin networks are doing. So with Flannel or VeeFnet or CubeNet or whatever is out there, the overlay network inside of the Kubernetes cluster is built and handled. Here you see how an actual application is running on AWS. So you remember the green ones, they are the master control plane. In the case of AWS, you don't really see them, so it's fully handled for you. And the blue ones are the worker nodes. And the worker nodes are fully visible. In case of normal EKS, you see them as EC2 instances in your environment, in your VPC. And then the pods are started on these worker nodes. So for example, if you do a deployment of an application on that Kubernetes cluster, these pods, they come online, they pull their images from an image registry and then start these Docker images on these worker nodes. So that here you also see on these worker nodes, obviously a CRI, container runtime interface is running. That could be either Docker or Containerd or Creo or anything like that, that actually runs your containers. And then there are interfaces for network communication. That's, for example, kubeproxy. And obviously the control processes to see that these worker nodes are really live. And Kubernetes is a fully distributed system, so meaning you can have lots of these worker nodes. Obviously, you need to adhere to the sizing guidelines, but a medium-sized cluster can easily have dozens or even hundreds of worker nodes established there. I have heard of clusters that have 5,000-10,000 nodes, large clusters for Netflix or any of these huge workload providers. They do use a lot of Kubernetes nodes to process all these containers. What I haven't mentioned yet is the image registry is usually not part of Kubernetes. So if you want to run a Kubernetes cluster, you need to have a space where you can store the registries. So Kubernetes does not provide that. Luckily, with AWS, we do have ECR, which is the Elastic Container Registry, which provides a fully OCI compliant image registry. You can store your Helm charts and your Docker images and other images that you require on your Kubernetes cluster. What is also not part of the Kubernetes cluster is the build of these images. So you need a pipeline that actually builds and stores these container images. That's also not part of Kubernetes. But there's a huge ecosystem that actually can do that. For example, GitLab or Code Pipeline or any of these build tools can these days build easily container images. Going a bit into networking. Networking is quite complicated with Kubernetes because it is a distributed system. It needs to have a cluster networking. It needs to have internal load balancers. It needs to have integration into the public cloud provider network. And actually, Kubernetes has that really well thought out and also very sophisticated networking built into the Kubernetes solution. And you probably can easily run Kubernetes with an integration into the networking relatively easy. However, if you get into troubles and something doesn't work well, it's it's advisable to understand how full Kubernetes networking is working. And with all these various elements in the Kubernetes networking space, it can be confusing. For example, the internal load balancers, they are called service. That's a Kubernetes API object. They are called service. It's actually a layer 4 load balancer used internally to distribute load coming in over the running pods. The load balancer, the service in load balancer mode in most public cloud providers can also interface via the controller manager into the cloud platform and establish external load balancers so that communication can flow in from the provider network easily into the Kubernetes cluster. So highly integrated, highly sophisticated layer 4, layer 7 load balancing built into Kubernetes and really well integrated into the cloud providers' offerings. Now coming to more objects of Kubernetes, looking at deployments and pods and replica sets over the next couple of slides. People get a bit confused with Kubernetes because they don't use the same names as Docker does natively. So if you have worked with Docker, you know the concept of a container and a container image. Actually, Kubernetes doesn't use containers. The smallest atomic unit is actually a pod. So when they provision something in Kubernetes, they provision a pod. And the pod is always running on a single worker node, and it can contain one or more containers and container images. So that's something to remember. If you have a pod with multiple containers, then they all run on the same node for that particular pod. Then what controls a pod is a replica set, and the replica set is a construct that is used to ease upgrading and ease versioning of life cycles of these pods. And then what controls a replica set is a deployment. So usually when you start to work with Kubernetes, you deploy something and you don't see the replica set in action. You actually have to go look for the replica set. But as soon as you have as soon as you have a deployment, you also have a replica set configured. And if you remember the hierarchy, a deployment controls a replica set controls a pod, and the pod consists of one or more containers. You have grasped the concept of Kubernetes with the pods and containers, how they are controlled. Now, coming a bit to the replica sets. The replica sets are really a clever construct. How updates are applied on the deployment level, on the pod level, on Kubernetes. So if you deploy an application at version 1, you have one replica set that is deployed. So you do one deployment, it gets one replica set, and for example, the application is at version 1. Everything is up and running, everyone is happy, and now the application dev wants to upgrade the application image, the Docker image running here. So he goes and updates the deployment. He doesn't do a new deployment, he just upgrades the existing deployment, changes the Docker image tag. And now, because Kubernetes is a declarative system, what it does, it will create a new replica set and will start a rolling upgrade between the two replica sets. So when this process is started, it will kick in a replica set with 0 replicas. It just prepares everything. And if the preparation is well, it will start to create a new pod. So it says this replica set here will have one pod. If that pod is coming up, the health checks are okay, it starts to kill that pod over here. So it basically says this replica set should be 2. And then here the new replica set will be increased to 2 pods. That one will be killed. Then it goes to 3 pods. 3 replicas, and then this one here is killed. And if all is well, the upgrade has happened, we had a proper rolling update, and this replica set is deleted, and we have again 1 deployment, 1 replica set, and 3 pods. But during the upgrade, you could see more pods joining. You could see 2, or you actually will see 2 replica sets. But that is sometimes confusing for people. The cool thing is, because of these replica sets, we actually can roll forward and roll backwards changes, deployments, and that's a really cool addition. Just a word of caution here, Kubernetes only does out-of-the-box rolling upgrades with these deployment objects. If you want to have something more sophisticated, like blue-green or canary releases or A/B testing or anything like that, you need to use first a service mesh that can steer the traffic between the various deployments, and a control mechanism like a CD tool that has the ability to do these fancy deployment methodologies. Good. So, any questions to me before I start the demo? No, good. We are very well in timing, so we do have about 10-12 minutes left for the demonstration, and I will show you a couple of things on AWS with EKS. So with EKS, as mentioned before, is part of the container solutions, container services at AWS. So if you open ECS or EKS or ECR, you see all those 3 solutions at the same place. So you can easily change between ECS and EKS on the UI side, not on the deployment side, on the UI side, because they are all clustered together here in the same UI. Then to create a cluster, I have already done one because it takes a bit of time, but I show you how it will go in the UI. So to create a cluster, you just go into EKS, create a cluster. You need to give it a name, test1. You need to choose the Kubernetes version, and you see it's pretty actual. The current release is 1.19. So Kubernetes brings out a new release every quarter. So I believe in August 1.19 was released, and they already have 1.80. I do expect that in a few weeks or months you even see 1.19 here. And then you can give it a service role. If you don't have one, you need to create one. That's actually the control plane to AWS resources role that you can do. I have created my cluster with CloudFormation, so that was already prepared for me. And I can encrypt the Kubernetes secrets with KMS, which is really handy to do so, because these secrets are not really encrypted by default on Kubernetes. So having AWS doing that is pretty nice, much more secure, obviously. Here I need to pick a role. Then I go next. Then you need to pick, obviously, a VPC. Then you can choose your subnets. You don't want to have your Kubernetes cluster on the internet, so you choose private subnets. So let's say, for example, I use a few of my private subnets that I have created. That I used 2. Then I can apply a security group, how they can communicate with each other. I show you later on what other security groups we do have. So quite a few. That's probably the wrong one. Here, that one is quite good. Good. Then I can configure the internal Kubernetes networking CIDR. So that's actually Kubernetes networking inside uses private addressing, and that's what you can configure here. Then you can say if it will be a public cluster. You shouldn't actually do that. A public and private cluster combined, or a fully private cluster, which is the preferred thing, so that your Kubernetes control plane API is only reachable via an endpoint in your VPC. Then you can say you want to integrate it into the CNI, the VPC CNI. That's actually also quite convenient. Here, I don't want to do that. Here, continue. Then you can say about the logging. If you want to have full audit logging enabled and sent to CloudWatch. And then you have a review and create. And if you press here, create, it takes about half an hour. And your cluster will be up and running if you have configured it correctly. Because we don't have the time, I have pre-configured a cluster this afternoon. You see I have provisioned it at 1.15, which is an older version, to show you that there is also an update button. So that's the only thing that you need to do. Press here, update, and then it upgrades the control plane and lifts it to a new version. So it's super easy, super convenient. That's the first thing. And the second thing, it's highly tested from AWS. So when AWS releases these Kubernetes versions, you are sure that they will fit well into the AWS ecosystem. And as you know, EKS is a fully managed product from AWS, so you also get support from AWS, so you can open cases, and you basically have also Kubernetes support included with AWS, which is quite convenient as Kubernetes can be quite complex when you start to work with it. So let's go into the cluster that I have created. Let's start here. So the first thing that you see is the nodes. So as mentioned before, the control plane is fully handled outside of your VPC. You don't see anything here, but the nodes to run your workload, so these are the worker nodes, are fully visible, and you see them here too. Then also, a new thing is that AWS now also peeks into your Kubernetes cluster. So you see what kind of deployments are running on that Kubernetes cluster. And that has improved quite a bit over the last couple of months. So if you upgrade to higher versions, you see more information here with your workload running on that EKS cluster. Then going to the configuration, you see the roles that I have specified. You have some OpenID stuff that you can use. Here is the server endpoint where you can attach to. Let's go to compute. Here you see everything is handled with a node group. That means it is fully auto-scaled. Here you see the auto-scaling group, meaning if I click onto that, it brings you to the classic EC2 auto-scaling things up. You probably recognize these things: min capacity, desired capacity, maximum capacity. You can also set automatic scaling if you want so with scaling policies. For example, you want to go fully fancy and scale on request count. If there is a correlation between load and your worker nodes and request counts, you can do so, or you can go the classic way with CPU utilization. Click that in. If the nodes go above 50% CPU for a certain time, new nodes are added according to the policy. You can also scale out. You know that from your EC2 usage. So same happening here, and the really cool thing is there's also some self-healing in there. So if something happens to these EC2 instances, so for example, if some idiot goes in here like me and terminates these instances, so this is a running worker node, and I terminate such an instance, it actually shuts down what happened. Because it is an auto-scaling group, it will be a violation of the desired state. And in a couple of minutes, this EC2 instance is replaced and fully set up again and ready to take again the workload on these worker nodes. So fully integrated into EC2 auto-scaling, that's really well done. Then on the, let's go back on the networking side. You have seen before the subnets that I have chosen. These subnets are private subnets plus something to connect to the control plane. And here I have made my control plane public because it's easier to reach it. But in an enterprise environment, you probably will have that in private mode, fully locked down, with a closed security group, and you can even use classic security groups to control the reachability of that cluster Kubernetes API even further. So here you see those folks can talk to, and there is another security group used to control traffic between the worker nodes and the control plane. So you can use the tools that you have used before. So you see that the cluster can communicate inside itself, but you can control that if you want to have a highly controlled environment. You control that with the security groups that you define. And of course, the logging here is the control plane logging. So everything that is created audit-like. So every action could be forwarded to CloudWatch so that you can analyze it with your normal tools that you use. And here the update history, you see I have updated 2 times the API and also did a version update. Could do 1 more, or actually 2 more from 15 to 18. It's actually 3 more that I could do. To have the cluster on the newest level. So now switch over to the actual. Now I show you here. We have built the Kubernetes cluster with CloudFormation. When we do stuff at Kubernetes, we usually do that in CloudFormation so that we have infrastructure as code. We have done here the same. So this was created with the CloudFormation template that we can parameterize. We can say how many nodes, the versions, the sizes, and stuff like that. And then we can get the Kubernetes configuration, the API configuration with this command. It's very convenient. You don't have to look for these strange commands. You type it in. And then you get your shit. Okay, should have prepared that better. And need to stop briefly the sharing so that you don't see my password. Sorry about that. Hopefully, yes, good. Here, which one is it? This one here. Good. Coming back. I've now. Where can I share? I think it's here. Screen sharing. Come on. Was that correct? Yes. Can you see my screen? Yes, thank you, Phil. Thanks for that. Sorry, timed out too restrictive these things. So let's go back. Now I want to have again that Kubernetes configuration downloaded. So let's do another try. Here it is. No, it is expired. What's going on? It doesn't want to update that. It did work 2 hours ago. Yeah, I could troubleshoot it now, but actually time is running. I only had a couple of minutes left. So what I can show you, now it's not running, sorry. Yeah, anyway, sorry, that doesn't do what I wanted to do it. So I actually wanted to deploy a small application with Helm to that Kubernetes cluster. but as I only have 3 minutes left, I don't have the time to troubleshoot that now. Sorry about that. If you're interested in seeing a deep demonstration, reach out to me, and we will set up a private session for you so that you can see how an application is fully deployed to EKS. Good. Now, coming to a closing, any questions from you folks about the demonstration or the slides that you have seen? I assume that's a no. So we are now we are coming to the closing. So first thing, we are in December. Thank you very much for the partnership that we have with most of you that are attending. Thank you so much. We wish you a Merry Christmas and Happy New Year. Really looking forward to a better 2021. If you can help with anything, reach out. I'm not sharing. No, I'm sharing. If we can help with anything, reach out. We will be here for you. Thank you so much. Good, and this was the last webinar in this webinar series. So there is not another one scheduled so far, but we certainly will do more webinars in the future. We just haven't scheduled them yet. So for those of you that have participated in all of them, thank you so much for your time. I hope it was interesting for you. Looking forward to work with you in the future. So that's it. Thank you so much for everything. Talk to you soon. Looking forward. Wish you all a great year end. Stay healthy and safe, and goodbye. Thank you.